kind of already did the series. So we're going to go fast with the series. We're not going to get to all this today. Okay, tell me everything you know about geometric series or sequence. Anything you remember? Yes, very true. For arithmetic, we had a difference of d, right? So the n is in an exponent because the difference in a geometric series is a constant rate. So it's no longer subtracting the terms to get the difference. We're now finding a rate in between terms, and that is what's going to be in a geometric sequence. So a sequence is geometric. It has when a ratio of consecutive terms are the same. Now, how do we get that rate? I would take the very first value, put in the denominator of the second value. I want the greater value, greater term on top. And it can keep going forever. And it should always be the same. Keep going, keep going, keep going. And this should equal whatever our rate is, which is our r. And r can never be 0. Because that's just, the same number over and over and over again. R is called a common ratio. So we don't have a common difference anymore. We have a common ratio.
What's the part where it says
equals r? So when I take like a number, let's say 4 over 2, that's going to equal what?
Oh, actually, I get it. When it says it can't be equal, I was thinking it was plus or minus. I don't know why I thought that, but that makes sense.
Yeah. It's a consistent ratio we're going to get over and over and over again. And most of the times, our r is going to be the exponent. So I want you to write a rule. Write the rule. Start off with an easy one. I'm surprised you guys don't have food. You guys like always have food. To enjoy your time while you're here. Okay, I'll give you another one, but let's go over the first one. Let's find our ratio. Take my second term, put over my first term. This should be the same as 6 over 4. It should be the same as 8 over 4. All of these should be the same to check to see if it's a geometric sequence. What is the first one simplified to?
8 over 4,
8 over 6. What is the first one simplified to? 2. Second one? 2 and 3/2. What about the last one? 4/3. Is this a geometric sequence? Nope. Great. Next one, we have 36 over 12. Should equal the same as 108 over 36. Should equal the same as 324 over 108. First one should simplify to what? That's the easy one. 3. I gotta use the calculator for the other ones. Should be. Yeah, 3. Oh. 3. Last one, 3. So we start off with our 3 to the n. Am I done? No. If I put a 1 here right now, my first term would just be 3. My second term would be 9. So what do I have to put out front so that my first term is 12? 4. Boom. Try the third one on your own, and I'll put down a fourth one. Oh, you're leaving?
Yeah.
Right from here?
Oh, you'd be after the end of school.
Oh, yeah. Okay, number 3. There's a lot of keep change flips. Do we all do keep change flip? Do you all know how to do keep change flip? Do we know what I mean when I say keep change flip? Yeah, yeah. Okay. What do you guys say?
It's trying to like say it. We just multiply by the triple.
Oh, we had this conversation, didn't we? Some people like don't know what it is. When I talk in like geometry and algebra, we went over. Well, you start from the bottom and you work your way down. So you keep the top. Next one down is division. So what's opposite of division? Yep. And then last thing, we flip it. So we have negative 3 over 1, which would equal negative 3 halves. So that should be our common ratio. What should be out front? Yeah, invisible 1. Nothing should be out front. That's our first starting term. Because it's our first starting term. So once you get your rate, you just want to be like, hey, how can I change this rate so that my first term is what it is? Yeah. And then it should keep going and keeping the same. Are we done with 4? Okay, keep going.
Oh, wait.
Yeah, there's one more. Mm-hmm.
That goes on the outside, right?
Should only be affecting your R. Mm-hmm. Okay, that is the answer to the last one. Have any questions about how to get the rules? No? Great. We can write this in the equation form. So we're trying to find the nth term. We're going to use this equation. So find, ooh, that's too small. So find the nth term of a geometric sequence. So you kind of already found out what this formula is. Starting with, we have a of n equals our very first term times r, but n is minus 1. Negative 1 is going to be very important, and you're going to forget about it sometimes. but it's okay. Let's do an example. Okay, I'm going to give you a sequence. Say 5, 15, 45, and so on. I want you to find the 12th term. So we're missing two things right now. Well, we know what n is going to be, but let's find r. We need to find r. Find r. How can I find r again? Glenn, how do I find r? Mm-hmm. It should equal the same thing. What is the first one equal to? Second one? 3. Perfect. So we found our r. Now we want to find the 12th term. So we have a sub 12 equals our very first term, which is what, Dolan? 5. Yep, and we're going to multiply by our weight, which was 3. We're going to do 12 minus 1. So that should be 11 up top. Karina, what did you get when you multiplied this all together? Mm-hmm. That is the 12th term in that sequence.
That's like so much bigger than I thought it was.
Oh, they're going to get a lot bigger. Mm-hmm. Okay, boards. We're going to do some problems on the boards. Ready? Oh, we only have, we got 10 minutes. We'll do a few. See how we go. Christina, want to grab the cards behind you and hand them out? Yeah, that's the one with the diamonds.
You see solid, bro?
It's okay. Wait, let me.